In this video, we are learning about ray optics and optical instrumentations, CBSE class 12th. In this chapter, we will see the reflection of light. Nature has endowed the human eye with the sensitivity to detect electromagnetic waves within a small range of electromagnetic spectrum. Electromagnetic radiation belonging to this region of the spectrum. Wavelength of about 400 nanometers to 750 nanometers is called light. It is mainly through light and the sense of vision that we know and interpret the world around us. We need to understand a few basic concepts over here. Light travels with enormous speed. The speed of light is 3 into 10 power of 8 meters per second. It travels in straight line. A light wave can be considered to travel from one point to another along a straight line joining them. The path is called ray of light. A bundle of such rays constitutes beam of light. Light exhibits certain properties such as reflection, refraction, dispersion, scattering, etc. We can understand what is reflection of light. When a light ray incident on a reflecting surface, that is AB, assume that it's a mirror, and PQ is incident ray. PQ is incident ray, incident at point Q, then it bounces back to QR, is a reflected ray. When a light ray incident on a reflecting surface AB, then it comes back into the same medium. This phenomena is called reflection. The angle made by the reflected ray R with the normal is called angle of reflection R. The angle made by the incident ray PQ with normal N is called angle of incidence I. In case of a plane mirror, the angle of incidence is equal to angle of reflection. We need to understand about sign conventions. In a Cartesian system, we can understand about the Cartesian system, there is x-axis as well as y-axis. In sign convention, we have to take x-axis as well as y-axis. Once you can consider there is an x-axis and y-axis, the center point is origin. Right hand side positive x-axis, left hand side negative x-axis. Top positive y-axis, down negative y-axis. Assume that you have placed a convex mirror. What is convex mirror as per the definition? Bulged outwards as a reflected surface, bulged inwards as a coated surface called as convex mirror. Now, the first point you need to understand, all the distances are measured from the pole. The object is always placed on the left hand side of the mirror so that the direction of incident light is from left to right. Distances are measured, the direction of incident light are taken as to be positive. Now, the focal length, say an example here, this is F. The focal length PF, the distance between focus point and pole, is called as a focal length. And the radius of curvature, let's say that is BC, are taken as positive. Distances are measured, opposite direction of the incident light are taken as to be a negative. Distances are measured downwards, perpendicular to the principal axis, taken to be a negative. Now you can understand that here this downward distance of image, inverted image. Downward height, we have to consider negative. Distances are measured upwards, perpendicular to the principal axis, are taken as positive. This is positive. Next. There is a question for you. When light ray incidents on the reflecting surface, then it comes back into the same medium. This phenomena is called option A, refraction, option B, reflection, option C, total internal reflection, option D, both A and B. Right answer is reflection. Second question. According to the laws of reflection, option A, angular is less than angular. Option B, angular is greater than angular. Option C, angular is equal to angular. Option D, angle I is not equal to angle R. Right option is angle I is equal to angle R. According to Cartesian sign convention, in case of a mirror, option A, all the distances are measured from pole of the mirror. Option B, distances are measured downwards, perpendicular to the principal axis, are to be taken as a negative. Option C, distances are measured in the direction of incident light, are to be taken as a positive. Option D, all of the above. Right answer is all of the above. Now, focal length of a spherical mirrors we will study now. A parallel beam of a light, after reflecting, converges to a point on the principal axis is called focus. The distance of focus from the pole is called focal length. Now, we can define the relation between focus point or focal length and radius of curvature. You can understand in this diagram, there is a concave mirror we have chosen. There is a concave mirror we have chosen. Yes. And AB is the incident light. It is incident at point B. Then it is reflected. This is reflected ray. And when an object at infinitive, which means light ray parallel to principal axis, reflected ray goes through focus point. Develop the focus point, center of curvature. Okay. Now, pole and focus point between that, this is the focal length. Center of curvature to the pole, radius of curvature. Now, from the center of curvature, we have taken a normal. So, from normal to incident ray, incident angle, normal to reflected ray, reflected angle. Now, this normal makes a principal axis with alpha. There is an angle. Okay. According to laws of reflection, angle I is equal to angle R. Now, AB is parallel to PC. AB is parallel to PC. In this case, angle alpha is equal to angle I, which means here both angles are equal. Angle I is equal to angle I. Now you can compare with triangle BFC. BFC, there is a triangle. There is BFC. You can see this triangle. In this triangle BFC, refracted angle is equal to alpha. Both angles are equal. Hence, CF is equal to FB. We have studied in triangles in class 10th. Both angles are equal. Their opposite sides are equal. According to that, CF is equal to FB. Now, for a mirror of a small aperture, FB is identically equal to FB. Therefore, CF is identically equal to FB. Now you can see the CP is the principal axis. CP, we can write it as CF plus FP. CF plus FP. So both are equal. We can write CF is equal to FP. On the place of CF, FP you can substitute. Plus FP is equal to 2FP. So finally, CP is equal to 2FP. What is CP? Radius of curvature R is equal to double of FP, focal length. R is equal to 2F. Hence, F is equal to R by 2. Now the focal length is equal to half of the radius of curvature. There are a few questions. Question number 1. The focal length of a spherical mirror is option A, maximum for red light. Option B, maximum for blue light. Option C, maximum for white light. Option D, same for all. Right answer is same for all. Second question. If a spherical mirror is immersed in a liquid, its focal length will be option A, increases. Option B, decreases. Option C, remain unchanged. Option D, depend on the nature of the liquid. Right answer is remain unchanged. Now we can study mirror equation. We have to derive the mirror equation or the relation between object distance, image distance, and the focal length. Figure shows image A dash B dash, which is downwards over here. It's a real image of an object of AB. formed by concave mirror. From this figure, there are right angles A dash, B dash, F, this is, as well as MPF, this is. Once you can think these two triangles are similar, we will study further how to derive this. Now, AB is an incident ray. Sorry, AB is an object. AM is the incident ray. Now, whenever AB is the object, from the pole that is BP, we can mention BP is equal to object distance U, but as per the sign convention, minus U. Once object is here, assume that image is formed at B dash A dash. Now B dash P is equal to minus V. Okay. Image distance V, which is left hand side, minus V. Now the radius of curvature. Radius of curvature CP is equal to minus R, which is double of the focus point. Now there is a triangle A dash B dash C. Triangle A dash B dash C is identically equal to triangle ABC. A dash B dash C is identically equal to triangle ABC. Both triangles are identical. Therefore, A dash B dash by AB is equal to CB dash by BC is equal to CP minus B dash P by BP minus CP. I'll tell you how it is. CB dash in the sense of the total length CP minus BP dash. So we can get CB dash. Coming to BC. BP minus CP. What is CP? Minus R. Minus R. Minus B dash P. B dash P is minus V. Minus of B dash P. Minus of minus plus V. By what is BP? Substitute. Minus U. What is the CP? Minus R. Minus of minus plus R. Okay. Now, as you know that angle A dash P B dash is equal to angle A P B. A dash B A dash P B dash, which means this angle, refracted angle, reflected angle. A P B incident angle, both are same. Angle I is equal to angle R. Therefore, triangle A dash B dash P is identically equal to a triangle A B P. Both this angle A dash B dash P A B P. I'll change a color for you. A dash B dash P as well as triangle A B P. These two triangles are identical. Now, A dash B dash by AB is equal to B dash P by BP. So what is B dash P? Minus V by minus U, which means V by U. Okay. Now, A dash B dash by AB. A dash B dash by AB value how much? Minus R plus V by minus U plus R. Here also A dash B dash by AB is equal to V by U. So both you can make it as an equal. After that, do the cross multiplication for simplification purpose. So minus UR plus UV is equal to minus UV plus VR. So plus VR, minus UR, take right hand side. So UR plus VR. UV also take other end. R this UV take this end. So which is UV plus UV, 2UV. UR plus VR is equal to 2UV. R you take common. U plus V is equal to 2UV. So finally, we got R is equal to 2UV by U plus V. What is R? 2F. Yes, 2F is equal to 2UV by UV. R. Very easy method. What you can do, without taking common, divided by UVR. Again UVR. Both sides UVR divided. UV will be cancelled. VR will be cancelled. UR will be cancelled. Finally, 2 by R is equal to 1 by U plus 1 by V. R is equal to 2F. 2 by 2F is equal to 1 by U plus 1 by V. 2 will be cancelled. Finally, 1 by F is equal to 1 by V plus 1 by U is the mirror formula. Hope you understood. If any doubt, type in a chat box. Now, linear magnification. The ratio of the height of the image formed by a spherical mirror to the height of the object is called linear magnification. M is equal to H dash by H. H and H dash will be taken as a positive or negative in according with accept of sign convention. A ray diagram for the formation of the image of the mobile phone is shown in a figure. There's a question for you, application. The image of the part which is on the plane perpendicular to the principal axis will be on the same plane. The part which is at C will be imagined at C and will be the same size. Object size is equal to image size at the same. The other end A of the mobile phone is highly magnified as distance of the image is linear functions of distance of object. The magnification is not uniform. There are questions for you. Equation of linear magnification is option A, V by U, option B, VU, option C, U by V, option D, minus V by U. Right answer is minus V by U. The expression for mirror equation, option A, 1 by V plus 1 by U is equal to 1 by F, 1 by V minus 1 by U is equal to 1 by F, minus 1 by V plus 1 by U is equal to 1 by F, 1 by V plus 1 by U is equal to minus 1 by F. Right answer is 1 by V plus 1 by U is equal to 1 by F. There's a question. Suppose that the lower half of the concave mirror's reflecting surface is covered with an opaque material. What effect will this have on the image of an object placed in front of the mirror? Answer. You may think that the image will now show only half of the object, but taking the loss of reflection to be true for all points of remaining parts of the mirror, the image will be that of the whole object. However, as the area of reflecting surface has been reduced, the intensity of the image will be low. Next question. A mobile phone lies along the principal axis of a concave mirror as shown by a showable diagram. The formation of its image explain why the magnification is not uniform. Will the distortion of the image depend on the location of the phone with respect to the mirror? Answer here. The ray diagram for the formation of the mirror of the phone, the image of the part which is on the plane perpendicular to the principal axis will be on the same plane. It will be of same size. So B by C is equal to BC. You can yourself realize why the image is distorted. Now there is a question. An object is placed at 10 centimeters, 5 centimeters in front of a concave mirror of a radius of curvature 15 centimeters. Find the position, nature, and the magnification of the image in each case. Now we can derive it. Object is placed at 10 centimeters, 5 centimeters in front of a concave mirror of radius of curvature 15 centimeters. What about the focal length? 15 by 2, which means 7.5 centimeters. Due to concave mirror, focal length is minus. Now the first question. Object distance 10 centimeters in the first question. Okay, we need to calculate image as well as magnification. So V value we need to find out, M value we have to find out. As you know that 1 by F is equal to 1 by V plus 1 by U. So 1 by V we want. 1 by V is equal to 1 by F minus 1 by U, which means 1 by minus 7.5 minus of minus 1 by 10. So after solvation of this, V is equal to minus 30 centimeters, you will get it. Then magnification M is equal to minus V by U, which means minus of minus 30 by minus 10, which means minus 3. So the image is magnified, real and inverted. In second case, what they have given? Object distance they have changed. In the same formula, object distance they have given 5. So here you should mention 5. Then V value you will get it 15 centimeters. Now again magnification. Minus 15 by object distance 5, which means 3. Okay. So the magnification is magnified positive 3 here, because minus of minus will be cancelled. Okay. Image distance we got plus 15. Plus 15 in this case. Now M is equal to 3V, which means magnified, virtual and erect. Plus symbol indicates erect. Next question. Suppose while sitting in a parked car, you notice a jogger approach towards to you. In the side view mirror, R is equal to 2 meters. If the jogger is running at the speed of 5 meters per second, how fast the image of a jogger appear to move when the jogger is A, 39 meters, B, 29 meters, C, 19 meters, D, 9 meters away. Here, radius of curvature R is equal to 2 meters. So focus point is 1 meter. Okay. Now object distance U is equal to, first one is 39 meters. Okay. As you know that as per the mirror formula, 1 by F is equal to 1 by V plus 1 by U. Okay. 1 by V is equal to 1 by F minus 1 by U. Okay. U minus F by Fu is equal to 1 by V. So V is equal to Fu by U minus F. Directly we alternated the formula as image distance. So we can substitute V is equal to minus 39 into 1 by minus 39 minus 1, which means 39 by 40 meters. Now, jogger is moving with the speed of 5 meters per second after 1 second position. Okay. Now, 39 by 40 minus 34 by 35. If you do that, then you will get that 1 by 280 meters. At the same way, object distance 29 meters, 19 meters, and 9 meters. Thank you so much. We'll meet in next video.